Hello, Professor Rashidi. This is my second project for design and manufacture, where I will explain design for sustainability and all its importance and all its details. So, first of all, I want to explain why design for sustainability is important. Right, there's a rise of attention for global warming and humans' impacts on the earth itself. And a lot of the resources that we use are finite, right? They're not going to last forever. So, designing for sustainability ensures that the way we live now will ensure for the next generation and that they will have still have be able to live in a comfortable life in a comfortable world, right? A world that's not dying and has everything it needs. We don't take too much from the next generation and it still leaves something for them. So, introduction, just introducing. Again, it's creating products, services, and systems that minimize environmental impact. But it's important that you don't minimize or like negate any of the efficiency for the product, right? A sustainable vacuum cleaner, for example, shouldn't be less effective than a regular vacuum cleaner. The sustainability aspect of it should just be a plus, right? Um, Obviously, there might be some concessions. It might not be 100% as good as the non-sustainable, but if it works half as good, people just aren't going to buy it. So you don't want to reduce the efficiency of the product and compromise it just to reach the sustainability goal. And there's a lot of areas to designing for sustainability. You need to worry about the material that's being used in the product, energy efficiency, energy on all aspects, right? The energy being used for the machines that are gonna create it, the energy being used in the product itself, of course. If it's being charged, how is it getting that energy to? A lot of that is important. The waste, right? What's gonna happen after that product is no longer usable? What happens to the waste that's being produced when you like make the new product? And then what happens like after the end of life of the product as well? And then life cycle thinking. Just think about every aspect of it again. From producing it to distributing it to acquiring the materials before you even do any of that to when the consumer has the product and then the end of life of the product as well. You need to think about every aspect of it and how that might affect the environment. So there's a lot of applications for sustainable design. It's really everywhere, right? Every product needs to be sustainable, ideally, if we want to help the world. Reduce carbon emissions, reduce global warming, make sure that there are resources, right? If half the products are sustainable, half of them aren't, then eventually, like the products that aren't sustainable are going to like run out, right? We're gonna run out of resources. So that's why it kind of applies to every single industry, from manufacturing, construction, architecture, transportation, energy, packaging, food. Everything needs to be sustainable, or really nothing is sustainable. But it's really cool because um, you can focus on individual, smaller consumer products, bigger consumer products like cars. They also need to be sustainable. There's been a push for electric vehicles, which I'll get into a little bit later. Energy, right? Energy. I guess I'll get into it now. Energy needs to be renewable and sustainable. Otherwise, anything that's powered by electricity isn't, right? If the entire electric grid is based off fossil fuels, those are finite, and if everything else is sustainable but needs electricity provided by fossil fuels, that's not really sustainable, including those electric cars. And then just packaging creates a lot of waste, and then food, we'll always need food. So there's some trends in sustainable design. um, Switching from a linear economy to what's known as the circular economy is heavily incentivized. There's push for new materials, discovering new materials, renewable energy, so switching from fossil fuels to wind or hydro, solar, that can be renewed, right? We'll never run out of these things. Reducing carbon emissions to net zero, and then AI has been used um, to help like manage waste manage and life cycle assessments. And then sustainability is interesting because it's one of the few aspects of design, well, other than safety, I guess, where government kind of enforces policies as well to make sure. So there's a lot of laws too. So previously I talked about materials. Some materials that are kind of growing in the sphere of sustainability is bamboo, right? Bamboo regenerates extremely fast. It grows very fast. Some species of bamboo can grow 2 feet in one day, right? So 2 feet over, an acre of bamboo. I don't know how many plants that is, but that's a lot of material every single day. So, there's furniture being made out of bamboo, which doesn't need to be hold up too great of a load. And since material is cheap and grows fast, you kind of make a lot of it. But it doesn't need to be too structural, right? So that's a good use for bamboo. Another big thing is biodegradable plastics. Some of these plastics are like plant-based, some of them aren't. But essentially, instead of just laying around in a landfill all day, they'll eventually break down into organic compounds, right? Water, excuse me, and other organic things that are found in the soil. Circular economy. So, like I said, there's been a push to switch from like a more traditional linear economy where there's raw material going in, and then imagine this was just straight, and it would end with waste, right? But nothing feeds back in. It's not a loop. It's just straight, and then that would be like a traditional product life. But in a circular economy, raw materials put in, and then you go through all the stages and lives of a product would go through in an economy, and then when you get to the end of it, some of the waste is circled back into the economy. Maybe not directly through that product, but maybe that waste could be used in another product line or product life, and that'll be beneficial. That reduces waste coming out of the circle. Ideally, if once this got refined enough, right, there would be no new materials going in, so the materials out about in earth wouldn't need to be mined anymore and gathered, and then there would be no more waste either. We wouldn't be putting anything else in landfills. That's the ideal case, of course. And then here's some more technology that's innovating the idea of sustainability. You have 3D printing, AI, blockchains, and green chemistry. So 3D printing is actually really big because it creates less waste than traditional like machining or something, because a lot of other manufacturing techniques are subtractive, right? So they reduce the material, but there's a lot of waste generated. But since 3D printing is additive, you kind of just add what you need. Sometimes there's supports and stuff that's kind of turned into waste, but if you could reuse that, then ideally there's no waste. And then AI is always good for analyzing things. And then shout out to the chemists, because they're the one discovering these new materials, understanding the material properties, making sure that they're safe for the environment, right? There's no harmful impacts on the environment, and they're testing to see what modern materials are detrimental, right? And then some essential skills is system thinking. You have to think about everything and how it interconnects. Material science, of course, very big. Life cycle assessments. Life cycle assessments are a type of software that analyzes the environmental impact of a product, right? Um, Including like where the materials are sourced, the type of manufacturing that's used, like casting versus forging, and the type of energy that goes into it. And you can see how much like methane or carbon dioxide is produced. It also includes like transportation as well and like energy use. Um, and yeah, this is my project. Bye.